Okay. So the first thing we want to do is we want to talk about the different types of bonds and their different properties. Okay. So the first type of bond is ionic. And then we're going to also do covalent and metallic. So different types of bonds. Covalent and metallic. Brand new one there. Metallic. Alright. So we can talk about different properties with each one of these things, like melting point, boiling point, that sort of thing. So for, let's say, like melting point,
High melting point.
it's going to be a high melting point for this, yeah?
High boiling.
And boiling point too. Let's just use melting point for now, because they're basically the same thing, it's just boiling is a little bit higher than melting. So high melting point for ionic. Over here for metallic, it's also going to be a high melting point. But covalent's a different one right here. It's going to be a low melting point relative to those. And you can explain this by their structures when they form bonds. So ionic bonds are high melting points because heat doesn't really disturb their strong magnetic attraction. When you have a lattice, you have positives and negatives that are right next to each other, and they're really, really strong magnets in between. So heat doesn't really break those bonds. Okay. Covalent bonds, on the other hand, they're sharing electrons. So you've got an atom here and an atom here, and they're sharing their electrons. So if you apply heat right here, it does break these apart, and you can melt because of that. Metallic, on the other hand, you've got these nuclei kind of arranged like this, and you've got a whole bunch of electrons flowing around freely. They're flowing around in a sea of electrons. Okay? So heat doesn't affect that either. Heat only affects the covalent bonds. It only affects these interactions we see when we light something on fire. So it'll melt something that's covalently bonded, but it won't melt something like a Bunsen burner. It won't melt something that's ionic or metallically bonded. Okay. All right. Now that's a basic property. We can also talk about electricity, conducting electricity.
I know
These
metallic conducts electricity.
Yeah, this conducts electricity.
Solid.
Covalent does not conduct electricity. It doesn't conduct heat either. Okay, it does not conduct. Ionic, it does conduct, but only when it's dissolved. So you can think about this. Now we can go back to this idea of dissolving this lattice. When you dissolve a lattice in water, here's some water. You dissolve a lattice in water, you've got a whole bunch of positives and negatives, ions that is, that are flowing around freely in water. Okay? So if you put, let's say you put two electrodes right here, and you put a really positive side over here and a really negative side over here for the electrodes, then all of these positives are going to be attracted over here to the negative, and all of those negatives are going to be attracted to that positive. So what that does, it allows current to go through that wire and continue going through that wire. Because all of the negatives, they give off their electrons, and it goes running through that wire. And all of these positives, they accept the electrons coming down from this end of the wire. This is the same kind of experiment we did in class, the conductivity lab. Right? So this allows things to be dissolved, or this conducts electricity when it's dissolved. This does not conduct electricity. This conducts electricity all the time. Okay? And it also conducts heat. You can say electricity and heat really well. That's why you don't touch a hot pan.
Yeah.
It'll burn you. Okay. That's it. Those are the properties. And those are the basic ideas. You don't really know anything else besides this. I won't ask you any other questions besides this kind of thing. If you can know why that they have a low melting point, it'll help you answer the questions. But you don't necessarily need to know why. It helps, but you don't necessarily need to know that. Okay? Questions on that? Good? It's a nice review?
Yeah.
Alright. Now let's talk about naming. Ionic and covalent naming. We don't name metallic bonds in this class. So that's bond properties, we got that. We cross that off. Let's do ionic and covalent naming. So ionic naming, let's continue doing that in black. Ionic naming. Ionic can be done with the regular style or with the transition metals. Hey, you're here.
What's up, guys?
Okay. Covalent, we'll do that on this side. Alright. We just did bond properties, man. We're going to go on to naming right now. Is that okay with you? Awesome. Good. Okay. So let's go from name to formula first. If you've given the name, you can tell me what the formula is. Okay. So for the regular ionic bonding, let's say I give you a name like magnesium chloride. Magnesium chloride. From this, you can tell me what the formula is. And the way you...
Formula is like the, what it represents, right?
Yeah, the symbols, yeah, like Mg, yeah. Just like that. So Mg is going to be involved, and we know that Cl is going to be involved too. So that's Mg, Cl is this. We don't know how many of the Mgs, and we don't know how many of the Cls yet. We just know that they're involved somehow. Okay, now we got to figure out how they're involved. How many of the Mgs and how many of the Cls. This is a long time ago, I know. So Mg, if you look at Mg, where is it in the periodic table? It's in the second column, yeah. So it's going to give, how many electrons is it going to give? It's going to give 2. Okay. And Cl is in the 7th column, so it's going to, how many is it going to get, or how many does it need?
1.
It needs 1.
So that means 2 chlorides.
So yeah, so if you do it the crisscross applesauce way, which we can do, or you can do little dots around here.
I did that.
You do the dots?
Yeah.
Okay, let's do that one. So you can crisscross it for 1, and then you'll know it's 2 and 1 over there. But let's do the dots. Let's say Mg is going to give away 2, and Cl needs 1. It needs 1, so I'll draw a little circle there. Okay, so if you're going to bond these things, Mg is going to give away 1, but now it has 1 more to give away.
So another chloride.
So we need another chloride. Oops, I did this wrong. There should be 1 there. There should be 2 there because I pointed to the right direction. I just didn't put it. And I didn't write down 2 and 1. So here we got the Cl over here again. 1, 2, 3, 4, 5, 6, 7. And now the last electron's going to go there, and that's going to be completely satisfied now. It's given away both of its electrons, and both of these have a full octet. So everybody's happy here. So it's going to be MgCl2 is the final formula. I just wrote it wrong the first time. MgCl2. Okay? That's a regular kind of example. Now, if I give you a formula, you can tell me what the name is. That's the easier way. So let me erase this part. So if I give you the formula, let's say I give you the formula Li3N. What's the name?
Lithium. That's covalent.
That's totally covalent.
Lithium nitride.
Yeah, lithium nitride. How did you know it's not that other way? Why is it not trilithium?
Because it's ionic.
Because it's ionic, and ionics don't have prefixes.
Is that the only way I'd be able to tell?
Also, this is a non-metal right there, and that's a metal. So a metal and non-metal, you're not getting these prefixes. If you've got two non-metals, then you use a prefix.
Oh, okay. Wait, lithium's not a metal.
It is a metal.
It is a metal? So
Yeah.
This,
It's on the left-hand side.
everything besides the fifth row is a metal.
Oh, you're
Everything
confused.
to the left of the fifth row is a metal.
You see the staircase? Everything
Yeah.
to the left of the staircase is a metal.
Okay.
Except hydrogen. Hydrogen is not.
Right. Okay. There you go.
Alright, so here's the two types of questions I can ask for this for the naming. I can say, given this name, what's the formula? Or given the formula, what's the name? This one is harder because you have to tell me how many of each of these molecules or each of these atoms are there. Right? That's hard. Here, the only hard part is to realize, oh, that's not covalent. If it's not covalent, it's pretty easy to name it. You just do the first full name and then put the I on the end of the other one. Okay?
Yeah.
Alright. Now, that's the regular ionic. Now we can do the transition metals. I'm going to give you a name. You tell me what the formula is.
Wait, I'm confused.
Transition metals are ionic bonds, but they're the harder type of ionic
Aren't
bonds.
they metallic? Not metallic. Aren't they? Okay.
Okay, let's say that I give you the formula iron 3 phosphide. How about that? Iron 3 phosphide. Okay, and now you have to tell me what the formula is. What's the formula?
So iron gives
That's the name. Now you tell me what the formula is.
iron gives off 3.
That's right.
So
Iron gives off 3, and how many does phosphorus take in?
5. It's 5 until it takes in 3.
That's right. So we have, let's just think right now. So we have iron giving off 3, 1, 2, 3, and phosphorus is taking in 2, 3, 4, 5. It's taking in 3.
So
So it's pretty even, isn't it?
so the FEP.
FEP. Yeah, you know me. This is going to be just FEP. Feb. Right? What about if I have something different? What if I have, I gotta think on my feet here. What if I have N NiN?
Nickel 3 nitrogen. Nope. Yeah. Oh, nitrogen has
What is it, Ben?
nickel 3 nitride. Or yeah.
Are you sure?
Yeah.
Okay, good. You're right. Nickel 3 nitride. It's just the way you said it. I didn't know if you were sure about that. Okay, now how did you figure that out?
What?
That's right. That's right.
Yeah.
How did you figure that out?
Because nitrogen needs 3 to the full raise. Oh, that's the same.
Yeah. So you know that there's nitrogen and there's also nickel involved with this bond. So nitrogen, you knew that it needed 3, 1, 2, 3 electrons. So that means that this nickel right here, it must have given up 3. Since there's only one of them, it must have given up 3. 1, 2, 3. So this must be nickel 3 nitride. You can tell these are trickier, right? These are trickier than this, but they're both ionic bonds.
Okay.
Right? Questions about that? So again, I can ask you a question going from the name to the formula, or I can ask you a question with the formula going from the name. Now the last layer here is covalent bonds. And I'll ask you the name, I'll tell you the name, you tell me the formula is.
On the test, will you give out the like the numbers, or we have to remember that?
The Roman numerals or the monos?
Yeah, like those.
Oh, I give you the prefixes. I give you 1 through 10.